Welcome to you all to the yet another lesson. This lesson is about date and time concepts and the changes thereof, change of time zones, etc. Understanding the concepts is very important for almost everyone. It's more so for a pilot who may be flying international in future, and he will keep having time zone changes very frequently. So a good understanding of the concept is important. Okay, let's visit some geography basics. We all know that the Earth revolves around its own axis, and of course there is the Sun. So we calibrated this time taken for the Earth to go around its own axis. Once we calibrated into 24 equal parts, and we called it each one as an hour. So there is a side which is exposed to the sun, and there is a side which doesn't really receive the sunlight, which we called it day and light. The point is, we need to understand that it's our division of the time into 24 hours, and of course, which is further subdivided into 60 minutes, and further subdivided into 60 seconds, and further subdivided into smaller parts for other requirements. Let's discuss some georeferencing system. Georeferencing system is all about indicating a place on the Earth in terms of a paper position, and so that anyone should be able to take the paper and identify the place exactly as meant by the original position. So there, to start with, latitudes and longitudes formed a very good base georeferencing system to indicate positions on the Earth. Of course, nowadays there are much more modern systems which have its base in the latitudes and longitude positioning system. There are other georeferencing systems as well, but latitudes and longitudes form a very good basic georeferencing system. Firstly, the latitudes. Let's just take the sphere of the Earth and divide it into two equal parts with an upper half and a lower half. The plane which passes through and the circle which it will cut on the surface of the Earth, this is called the equator. And of course, the equator divides the upper half and the lower half into equal parts. So this forms the basic referencing of the latitudes, and it is numbered 0. And thereafter, the latitudes are numbered to the north and south in an increasing order. It increases up to 90 degrees. That means from equator it starts at 0 and goes on up to 90 degrees and reaches the poles at the north. Similarly to the south. So that's latitudes. Similarly, longitudes. Just as we have the equator as the referencing latitude, there is a prime meridian for the longitudes, which is numbered at 0, and all the other longitudes are numbered east and west, and in an increasing order, numbered all the way up to 180 degrees. We will learn this in detail as we progress in the lesson. I just introduced you to the longitudes. As I told you, there is a reference longitude which passes through a place called Greenwich in UK. It dates back to historic reasons. We will look into the history a little bit in a short while from now. But it passes through that Greenwich, and so it is called the Greenwich meridian, which acts as the reference meridian. That means the 0 degree meridian passes through uh, uh, Greenwich. And the other longitudes, which are the semicircles, are numbered from 0 to 180, and they are annotated east to west, east or west, depending on its position from the 0 degree Greenwich meridian. So the entire surface is divided into 360 degrees of equal equal parts, so to say, and equal number of degrees, which is further can be calibrated into minutes and further calibrated in subparts if need be. Okay, we learned about longitudes. I want you all to understand another concept, which is a very important concept when we are on this subject of date and time, changes, etc. As we learned, the whole surface is divided to 360 degrees of longitudes, and we also learned that the entire surface is calibrated into 24 equal parts, which is called the hours, which constitute. I was going through the Wikipedia and found some interesting facts on this subject, so I thought I will share it with you. It's about a bit of history. The most accurate clock was invented in the year 1656, and the clock at the Greenwich Observatory was used by the British mariners. Let's remember that they were the earliest seafaring people. So they used to synchronize their ship chronometers for calculating the longitudes and the dates and the times. What was till then a convention slowly became an international practice, and that became a standard reference from the year 1884 onwards. I've shown the picture of the clock which is kept in the Royal Observatory at Greenwich. So we will go through some more interesting facts. Okay, some more history. I saw this picture of this external appearance of this London Greenwich Observatory. You can see the red ball and that tower. As I understand, every hour this ball would be raised and dropped so that people, the mariners, could take the clue of the exact hour from the dropping of the ball from a reasonable distance inside the sea. Thereafter, with the advancement in radio technology, the early radio time signals were broadcast from the observatory in the year 1924. To be precise, 5th February 1924. As the days passed, there were other countries and other mariners which were taken to the sea, and there was a need to coordinate their timings, etc. So there was a need for a central reference timing, and what was earlier called the GMT, which served as a reference only to UK mariners, slowly, conventionally, it changed over to universal time for the first time in the year 1928, and thereafter the radio clock started transmitting the accurate timings in the year 1972, and once for all, the term was confirmed as UTC, Universal Coordinated Time. Okay, let me explain this picture. I tried to show the world surface on a flat paper chart kind of a surface, and I've also tried to show the day and night towards the left half of the chart. So as we can see, the 0 degree reference, which is somewhere in the center of the chart, uh, it's sometime early in the morning, and to be precise, I have tried to show the time of 4:30 a.m. in the morning. Now let us analyze the places towards the east of this Greenwich meridian. Towards the east, the sun is already risen and day is already progressing well into daylight, and that's what the picture also shows. For example, a place like New Delhi, which is approximately about 82 and a half degrees east of Greenwich, if you were to calculate, the local time would already is around 10 a.m. in the morning. So, uh, so we come back to Greenwich. So, if when it is 10 a.m. in the morning at New Delhi, it is 4:30 a.m. The sun is just about rising, and it's early in the morning. Now let us go back and go further west and see a place. Let's take the example of New York, which is about 4 hours behind the timing of Greenwich Mean Time. So 4 hours, 4:30 a.m. minus 4 hours is approximately 30 minutes past midnight, which is what I tried to show in this picture. It's somewhere around midnight. It's dark in the of the previous night at New York. So once you understand this picture, you can understand the lesson very easily. Okay, let me introduce you to the concept of international date line. Let's appreciate uh, a new date on the Earth's surface has to happen at some place or around some longitude, and thereafter the day should progress. So this date line, or this is the longitude around which this is going to happen, is called the international date line, which let's explain further. Okay, to start with, I have shown the 0 degree, that is the Greenwich reference meridian, that is 0 degree reference meridian. Now, as we learned, it is numbered up to 180 degrees towards the east, and which is divided into 12 equal hours. Therefore, uh, the international date line is located about 180 degrees to the east and 12 hours ahead of the GMT. So, is it a straight line? No. What we have done for the sake of convenience, we have drawn a flexible line which it would cover the least number of land masses, and so that there is no confusion within a particular land mass for any date changeover. So it's a zigzag line around beyond Japan and beyond Australia, which is almost opposite of the 0 degree meridian, and the date changeover for any new dates happen around this line. So when one observer crosses from the uh, side to further east side, that is crosses the international date line to the east. So you have to subtract 1 day. That means you gain a day. And similarly, if one observer has to travel from the east side towards the west side, that is from say US or somewhere towards west, and crosses the date line, then you have to add 1 date, or you lose 1 date, so called. So this concept should be very clear, and once we see the examples, I'm sure you will be very clear on this concept. Okay, let's dwell into the concept of the international dateline some more, so that the concept is becoming more and more clear. Let us take an example of a situation where at around 0 GMT, that's the prime meridian, it's just about past midnight. So the places towards the east, they've already had their day well into the day, and at around international dateline, it is going to be around midday, because it's exactly opposite the 0 degree prime meridian. So let's move to the towards around the international dateline. So let's assume the date is around 25th July. That means it was just about a new date has begun in 0 GMT, that is just about past midnight on 25th July. Therefore, at around the international dateline, it's going to be midday of 25th July of a particular date, of the date. So, if you were to travel from the west of international dateline to the east, to a place east of international dateline, the time is of course going to be ahead, that is 1300 hours. But the date is going to be different. We are going to subtract 1 day. That means you are going to gain a date, which is going to be 24th July, 1300 hours. Similarly, if one were to travel, if one's position was to the east of international dateline at around this place, it is 1300 hours, but date is of course 24th July. Why? Even if you see the datum from 0 GMT, this place is still behind by 12 hours. So it's just about the new date at 0 GMT. So the new date is yet to begin in this place, which is towards the east of international dateline. So if an observer were to travel from 24th July 1300 hours position and cross the ideal to the west side, then he would encounter the time of 1200 hours, but the date will be 25th July. So I hope the concept is getting more and more clear. We are going to be seeing more examples so that you are going to be absolutely clear by the end of the lesson. Let's take a live example, and then we'll be able to get more clear on this concept. Let us assume an aircraft is located in Mumbai and it is due for a flight to London. So the crew do their pre-flight preparation and find that the flying time to London is likely to be 11 hours. And it is late in the evening, and let us assume the local time at Mumbai is 2300 hours on 4th August. So at that particular time, the time at London, the destination, is likely to be 1730 on 4th August. That is early evening on 4th August. It happens that the local time in London London is same as UTC, so we will talk in terms of UTC. So the difference between UTC and Mumbai or Indian Standard Time is 5 hours 30 minutes. So 1730 plus 530 is 2300. So everything is fine. So let's assume the aircraft took off at 2300 hours and lands in London. Okay, let's assume the aircraft has landed in London, and after flying time of 11 hours, the local time in Mumbai would be the next day morning 10 a.m. and the local time at London, which is also the universal coordinated time UTC, will be early morning of 5th August 0430. So 11 hours elapsed from both the sides, but the UTC timings would be different, and the local time, we will invariably translate the UTC to local time after calculating the UTC. So I hope the concept is very clear. We will see some more examples. Okay, let's see one more example. This time the flight is from New York to Dubai. Just to give you some record, New York is about 4 hours behind the UTC, and Dubai is about 4 hours ahead of UTC. Therefore, the time difference between New York and Dubai is a total of 8 hours. So let us assume an aircraft is due for a flight from New York to Dubai, and the takeoff is at 11 a.m. on 5th August in New York. So at 11 a.m. the local time, the UTC will be 1500 on 5th August, and let's assume the flying time is 13 hours of flying time. So at that moment, the local time at Dubai is likely to be. Okay, let's see another example. But this time it is an example where the aircraft will cross the international date line. Let us take an example of a flight from Hong Kong to Los Angeles. Incidentally, Hong Kong is about 8 hours ahead of UTC. Before I proceed further, I want you to notice the slight changes in the map setup which I have made, the day and night timings and the graphics. I want you to notice that. Anyway, let's proceed. Let's assume the universal UTC is 1630 on 6th August at this particular time, 1630 on 6th August, and therefore that will mean that the local time at Hong Kong, which is 8 hours ahead, is 0030 on 7th August, and at Los Angeles the local time would be 0830 on 6th August. Why? Because it is going to be 8 hours behind the UTC. And let's assume a flying time of 15 hours. Of course, this map and chart is not to scale, but the timings are a bit realistic. Let's go further. Okay, after the aircraft lands at Los Angeles, it's going to be 23:30 local time on 6th August at Los Angeles, and it would be 1530 on 7th August at Hong Kong, and of course the UTC will be 0730 on 7th August. Once again, I will expect you to do the maths and get clarified on the time changes. Okay, here is a much more interesting example. It's a flight from crossing the international date line from east to west, and the flight is from Los Angeles to Hong Kong. That's in the opposite direction. Let's assume that local time at Los Angeles is 2000 hours on 3rd August. That means late evening on 3rd August, and therefore the local time at Hong Kong would be 1200 hours on 4th August, and let's assume the flying time to be 15 hours from LA to Hong Kong. So now the UTC will be 0400 on 4th August. So let's proceed further. Let's proceed on the flight. Okay, after the flight lands in Hong Kong, it's going to be 0300 on 5th August local time in Hong Kong, and 1100 hours on 4th August, and of course the UTC is going to be 1900 hours on 4th August. I want you to I thank you all for watching this lesson, and please feel free to offer your comments on the email ID given below. We will meet with more lessons to offer in future.